Hey everyone, welcome to the session on creating an observability strategy via distributed tracing. My name is Chinmay Gaikwad. I am a technical evangelist at Epsagon. A bit about myself. I have worked in a different variety of roles at different companies. I started off at Intel and IBM, and I've also worked at some early stage startups. My hobbies include traveling, playing soccer, exploring video games. Although currently it's just restricted to video games, I'm looking forward to resuming traveling as soon as the COVID situation is over. So let's get started with the session. In this session, we'll look at how microservices have become the new normal and what challenges this has brought out. We will also focus on specifically the challenges in achieving observability in highly distributed microservices-based architectures. And lastly, we'll also discuss what a good observability solution should look like. So let's start with a bit of context on microservices. So hand in hand with the evolution of software, there has been a massive shift in the microservices architecture too. Today, 85% of enterprises are adopting microservices as their default architecture. You might have observed that these highly distributed modern applications are more typical than ever. Rather than being built in the data centers, these applications are now being built in the cloud. So these modern applications are highly distributed. That is, the application code is broken down into smaller pieces. And you can almost think of these as mini apps. They run independent of each other. So there is no one monolithic bundle of code. Microservices architecture has great benefits, no doubt about that. However, these easy to depict architecture diagrams from monoliths have started to become much more complex. And this has brought about a lot of unique challenges. Let's first see why enterprises are moving towards microservices. According to a 2020 report, scalability, speed of development, and decreased system administration are the top reasons. I'm pretty sure most of you fall in at least one of these buckets mentioned on the slide. Scaling microservices is extremely easy and can be done in seconds. It definitely increases your speed of development and allows you to efficiently utilize your resources. But as Werner Vogels once said, everything fails all the time. That is completely true. So that kind of brings new challenges while adopting microservices-based environments. So modern applications have now thousands of services, including databases, caches, and more. So visibility into them has become increasingly complex. Using traditional monitoring solutions, it can be nearly impossible to know what is going on under the hood. Let us see how we can troubleshoot distributed applications using a use case. Before we dive into the use case, let's first visit some fundamentals. Let's start by understanding what observability and monitoring exactly are. Monitoring tells you if the system is working. Observability lets you ask, why is it not working? So observability involves instrumenting systems to collect relevant test data. Thus, observability and monitoring are complementary to each other. In my opinion, observability isn't just a tool, it's a must-have culture for any organization. It's important for all, right from the developers to the C-suite. The three pillars of observability are very well known: metrics, logs, and traces. Let's discuss tracing later in the session. Let's start with metrics. Metrics are a great way for operations to figure out if something has gone wrong. Some examples of metrics include CPU usage or memory usage. We also have business level metrics such as bounce rate, revenue, click-through rate. Logs, on the other hand, can tell us why something went wrong. But when you have hundreds, thousands, or even 10,000 microservices running, these alone are not enough. Let's see why they are not enough. Let's consider an example of a virtual shop. As you can see, the HTTP server authenticates requests using Auth0 and pushes them to the Kafka stream. A Java container polls the stream and updates the DynamoDB table. Let's say there is a situation where users complain about orders that were sent but not handled. Where would you start? Maybe using traditional APM tools. The most common challenges in the current observability solutions are that their agents are very heavy duty and they have a lot of agents, one for infrastructure, one for application monitoring. So that kind of leads to higher resource utilization as well as developer time. There are also problems in pinpointing problem areas that leads to DevOps spending a lot of time trying to understand where the errors have occurred. Related to this same thing, alerts tell you when the problem occurred, but not where and why. Most observability solutions don't tell you the impact performance-wise each microservice has on your architecture, and that leads to a lot of complications as your application grows. All this leads to lower developer and business velocity. So using the traditional monitoring solution for a previous virtual shop example, you might start with looking at Kafka metrics. These metrics all look fine. There are no spikes or anything involved. So we look at other metrics. We then look at DynamoDB metrics, and you see a few spikes here. So you know something is definitely going on here. So we need to debug more. To effectively troubleshoot data, we need more data, that is logs. But are logs sufficient? And what gaps in the coverage are most often seen when only reliant on them for troubleshooting? We all know what logs look like. Personally, I have a love-hate relationship with logs. I love the fact that they are available, but I hate digging through them. Often I've found myself quickly scrolling through dozens or hundreds or even thousands of lines looking to spot the outlier. Similarly, I have sat and watched a live tail of logs flowing through. What if I knew the exact path a request is taking through individual services and components? Logs are good to debug monoliths, but they don't really work as starting point in a highly distributed architecture. While log aggregators help bridge the gap of centralization, on their own, logs still lack the context to an event or a metric that you're looking at. Logs are also heavy and poorly structured. Hence, it's even more challenging to determine what's going wrong. So in our virtual shop example, if you're very lucky, you'll be able to spot the problem, but it'll definitely take a long time. So let's recap of the things that are missing. It essentially boils down to correlation between metrics and logs, and between different services. The correlation will help us find the exact problem. So how do we correlate these pieces? That's where distributed tracing comes into picture. I'm sure most of you must have heard of tracing lately. Many vendors offer some form of distributed tracing. Even service meshes are now offering support for them. There are also dozens of open source solutions out there. However, where did it all begin and why? Distributed tracing was born out of Google over a decade ago, and it allowed engineers to trace a specific path a request makes through services. In effect, it helps shine the light on the needle in the haystack that logging and metrics can miss. Just because your application is made up of tens or hundreds of microservices doesn't mean that the request will travel through every single one of them. At best, it will travel through a fraction of those services. So using the same virtual shop example and distributed tracing, now you can see a focused view of the trace, which will help you identify the problem. In this case, it is a missing key ID. Which key ID though? Looking at the Kafka tree, you'll see that the username is missing. And now, when you focus on the Auth0 microservice, you see why is it missing exactly. Is it because of an expired token? So specifically for Auth0, you would like to use refresh tokens as the access token has expired. So in short, this reduces your mean time to detection as well as resolution by quite a lot as compared to traditional monitoring solutions. Let's look at some distributed tracing solutions that are out there. So let's first focus on the open source solutions. With distributed tracing, you have frameworks such as Jaeger and Zipkin. Recently, OpenTelemetry framework has tried to tie these pieces together and utilize. I love the work that the open source community has done with these frameworks. Although they are immensely helpful in pinpointing issues, but they come with a significant development effort. Let's see how one can instrument using OpenTelemetry. In distributed tracing, you would like to instrument every single API call within your code to create a building block of trace called span. A span represents work done by a single service with time intervals and associated metadata. You should collect and include in all your spans the relevant information, including payloads in many cases. By injecting and extracting identifiers from spans and API calls, you can correlate spans from remote services as well. So based on what we have discussed and the feedback that we got from our customers and industry experts, we at Epsagon decided to take an automated approach for our solution. So Epsagon takes a fully automated approach with our instrumentation and minimal maintenance requirements. Our agents should be able to collect data from any component within your stack, whether it is a service running in a container or function as a service or even traditional VMs. We are able to do this with rich context across metrics, events, logs, and traces. We can also allow you to search payloads or even custom tags. Observability should not only tell you if something has gone wrong, but pinpoint to where and why to help you reduce your mean time to detection and resolution. Observability should be on top of mind for every organization by now, but it shouldn't come at the expense of business or developer velocity. Distributed tracing solutions has numerous benefits. Let's look at an example of how you can visualize APIs and microservices using a distributed tracing solution. A typical architecture has a number of microservices involved. One of the most important features of an observability solution is visualization. Users should also expect actionable items within these complex visualizations or service maps. As we zoom in or filter on specific components, the user should be able to see the latency or even where the thresholds have been crossed. Metrics should be present to provide some context to the issues. When issues are identified in your application, distributed tracing solution should focus the visualization down to narrow the scope of services. It should also be able to filter down just to the downstream components. This would help take out the guesswork in determining the impact of the outage and where the latency is seen. Without smart filtering capabilities, an architecture diagram becomes nothing but an exercise in chaos theory. Another great benefit of a distributed tracing solution is to pinpoint where time is being spent in the code. Here is an example of a span which makes up a trace. Is a significant portion of the time being spent waiting for an external API call to respond, or perhaps we have an inefficient database call being made that needs refactoring. At Epsagon, our waterfall visualization can provide you with rich context of header metadata to help you troubleshoot in real time. At a business level, we not only need to look at traffic of our application holistically, which of course is important, but we should also look at it in the context of each service and component. In this example, we have a payment service that handles all of our processing, and the traffic there drops to 0. That's a huge problem, even if the traffic in every other service of our application is fine. And so we need to have the flexibility to slice and dice the data in n number of ways, with a couple of examples shown on the slide. We may also want to look at traffic at an application level, at a service level, or even at a resource type level. It's going to be a similar idea when it comes to errors. Not all errors are the same. An error that is critical in a service A might not be critical in service B. And so again, when it comes to understanding the error state of your application, you again need to look at it from different viewpoints. Maybe that's breaking it out by error code. For example, a user being rate limited is important information, but it's not as critical as seeing a huge amount of 500s. Further, we may want to be able to look at errors, not only based out of error code, but also based out of exception type. There are a number of ways you might want to visualize, track, and understand errors throughout your system, and it is a job of a good observability tool to allow you to do just that. So with all this information, you want to be able to monitor, alert on many kind of metrics from your system, metrics from the cloud provider, or metrics from Prometheus. As a user, you should be able to plan your observability in advance. Here are a few steps which you can use. First of all, you should be clear on what your business goals and development goals are. And then according to that, you should determine your approach, whether it's going for a DIY observability solution or managed. Both have their pros and cons. For example, for a DIY observability solution, you can take an open source solution and try to instrument it for your applications, but it will also consume a lot of developer time. Then you have to implement your observability solutions. And the final step is ensuring the scalability of observability strategy. This is really important because microservices, as you know, can scale within seconds. So if your observability solution can't scale with the microservices, it is of no use. So let's summarize what we have seen in this session. We saw that distributed microservices architectures come with their own unique benefits as well as challenges. Observability through metrics like throughput or simply seeing response time aren't enough to determine where the issue is and don't provide us with the necessary value to keep our environments healthy. Distributed tracing with context helps tell a story of when, where, and why a user has encountered an error. Finally, observability lets us get visibility into our architecture and reduce a bunch of costs associated with it. I would like to end the session just by saying that observability should be critical priority for your organization by now, and it shouldn't come at the expense of business or developer velocity. A great observability solution helps shift our mindset away from being reactive to being proactive. And that's it for the session. If you want to take the opportunity of going for our limited edition stocks, please visit the link as shown in the slide. Thank you again.